Hi everyone, so my name is Henrik Blixt. I'm a product manager with VMware, and I'm responsible for VMware Integrated OpenStack, or VIO for short. So as part of our previous release, 4.0, we introduced a container platform in that. So I was going to give you a little background on why we did that for a couple of minutes, and I'll show you a live demo, and hopefully that will all work just fine. So what are we doing with containers in VMware Integrated OpenStack? So one of the value propositions we have with VIO is the ease of management, ease of deployment, the fact that we're using the VMware SDDC underneath OpenStack gives us the ability to do some things, like cool things with upgrade, blue-green upgrade, that makes it really easy to upgrade and manage OpenStack. And we wanted to take that a step further and extend that to a container platform built on Kubernetes. So some of the enterprise-ready features with built-in security, HA, scale, easy to deploy, we can take with us from our OpenStack distribution. And then we wanted to make sure that the container platform that we have can take advantage of some of the goodness that we all know and love with OpenStack in terms of multi-tenancy, using Cinder-backed persistent volumes for storage, Keystone integration for authentication and authorization, and extending that to the container platform. And also extending the lifecycle management and making sure that we get that ease of use, ease of management, ease of deployment that we do with OpenStack as well. So just quickly, a quick high-level overview of the demo. I think this is probably not new for you. How many of you run Kubernetes already? No one? I got a couple. So just a high-level flow. We have, we assume that OpenStack is already installed, and then we deploy this container platform on top of it. And then the administrator goes in and create an OpenStack connection or an OpenStack provider. Basically sets up the container platform for provisioning the underlying resources for Kubernetes and for our clusters. And then we have the administrator going in and creating the actual Kubernetes cluster on OpenStack, running in the VMs. And this then sets the developer up to go in and deploy the application on these clusters. And then once the developer has done that, the administrator can go into the UI that I'll show you here in a second and scale up the cluster, both the worker nodes and the master nodes. So with that, I'm going to try and switch and see. So this is basically Horizon. So VIO, VMware Integrated OpenStack, is really, the OpenStack layer we have is really just OpenStack. It's upstream OpenStack running on Ubuntu in VMware VMs. So this is Horizon, and we'll log on here. So since we only have 20 minutes, I've pre-installed some of this to make sure we can get through the demo on time. So we have the Horizon dashboard, which is the regular OpenStack dashboard. And then we have our VIO with Kubernetes, or VIO-K as we call it, which is the UI here where the administrator will go in and create some of those things we just talked about. So the first thing we would do is create a cloud provider. So I have a file here already prepared with the answers, so you don't have to spend the next 10 minutes just watch me type. So basically, we set up this provider, we give it a name, and then we have two different provider types. One is OpenStack. So this deploys in two different ways. One is to deploy on a fully installed OpenStack distribution. So you just put this on top of it. Or we have something what we call a thin OpenStack, or an SDDC provider, which is basically a small containerized control plane of OpenStack that you can deploy on vSphere, and then we'll put this container platform on top of it. And then we have the regular OpenStack authentication. We set up our Keystone URL, the username and password, our OpenStack project names and domain names. We pick which image to use for the cluster nodes. We only have one Ubuntu image here, so we'll pick that. We pick the flavor we want to use. Since all these get deployed into VMs on ESX, we pick the image and the flavor. We pick a tiny one here. And then as choice of network, and there are 3 different networking choices. How many here are familiar with ESX and VMware networking? Some of you. So basically three different networking options. One is the VDS, which is the native standard switch that comes with ESX. And then there's something called NSX, which comes in 2 flavors, NSX-V, which stands for vSphere, and NSX-T for transformers. So 2 different flavors of NSX. So NSX-T replaces Flannel as the overlay. So when we use NSX-T for the networking, we can replace Flannel and basically use the same networking bridging between VMs and containers and remove one of those overlay layers there. And then we configure our security groups. So this environment is running in a nested environment, which means it's ESX running inside an NSX. So that's why it's a little slow here. It shouldn't be this slow. Oh, there we go. Select one security group. We select our network endpoints. We have one external network here. This is a little bit slower than it was this morning. So pick an external network, we pick an internal network to make sure we can have the pods talk to each other and make sure we can get into our pods. And then we get the configuration summary. So this is all you have to set up to create that connection into OpenStack, and that enables us to use those integration points with Cinder, Keystone in Kubernetes. So I have one already created here. So if you're going to look at this one, we can see the summary. We have something called node profiles, which is basically a way for us to create profiles, different profiles for the various nodes in Kubernetes. Because since these are VMs, you might want to size and create these VMs different depending on what node types they are and what workloads they're going to run. So here's the way to customize those VMs, the profiles for those cluster nodes. And here we see the integration with Keystone, the 3 uses that are available in Keystone that we set up for this cloud provider. So the next thing we'll do when we created and set up this cloud provider is to create a cluster. So I'll cheat the same way here and do my... So here we select our infrastructure provider that we created a couple of minutes ago. We can select the node profile. We decide the size of our cluster, how many master nodes we want to have, how many worker nodes, and then the cluster type, either share or exclusive. So an exclusive cluster is basically everyone gets access to the cluster, can do basically whatever they want. Right? And then we have a shared cluster, which is more of a multi-tenant environment. We create namespaces if we want to, if we want to have namespace for this cluster. And we select the users who will access to this namespace. And then that's basically it. And this will create the cluster, which is basically going to create the VMs in OpenStack. And since I've already done that, we can go into project here. Oops. So once we fire up the cluster creation, the container platform will talk to OpenStack, create the VM for the master nodes, create the VMs for the cluster nodes, and then we can give this information to the developers so they can start deploying their applications. So from the UI here also, since this is basically a regular container or a regular Kubernetes distribution, we can also look at the Kubernetes dashboard. So you can go in here and see, if you look at the cluster, we can see the nodes, the master node, and the 3 worker nodes we've created here, which then corresponds to the should correspond to the instances created in OpenStack. Which will hopefully come back any day soon. Oh, here. So you see the same nodes that we had in the Kubernetes UI. So from here, we can also download the kubectl config file. So we do that, and we get some of the information if we use the CLI to deploy our application. So we switch over quickly. So we're on a shell on our Kubernetes node. So here we have a YAML file that describes the demo that we're going to deploy, the application, which is basically a e-commerce website where you can buy socks. So this complete demo file here basically describes all the services, the load balancer, and all the volumes that are needed for this application. So as you can. And we also have the kubectl config file here. So if you do a kubectl get services, which have no services running on this cluster. No resources found. So you can see also if we go back here into the Horizon UI that there's one load balancer created here. And as we deploy our application, we'll also create a new load balancer for that application. Okay, so there's just one running there. So we'll switch back here, and we'll do a kubectl create -f. So now with kubectl, we deploy the services that were defined in that file we had here. So these will go and create the load balancer in OpenStack. It will create the networks. It will create all the mappings to the persistent volumes and whatnot, and also set up the external. So if you do a kubectl. Yeah. So now we see we have a bunch of services deployed. We have our card service, catalog, front end, order, payment, and so on. So now all these services running on Kubernetes. And if we give it a second, you can see that there's a pending external IP here on the front end. It takes a few seconds for that to register. But if we go into the Kubernetes dashboard and switch to our socks namespace, we'll see the same set of services here from the Kubernetes dashboard. And we still don't have the front end registered. Oh, there we go. Now you see we have the external IP here. That means that they have the load balancer set up and configured. So if we go back into Horizon and refresh this page, there should be a new load balancer created here. We have a new new row, a new load balancer created. So if we go back into our Kubernetes dashboard and click on our front-end service, should be an external endpoint here. So if you click on this external endpoint, that should take us to our SOX e-commerce application. So then if we see more use of this, we need to scale. We can then go back into our management UI here for the container platform, and basically just quickly from the UI scale this up and add more worker nodes for this cluster. So that basically concludes the demo. So I think we have a couple of minutes more if you have any questions. Yes. Sorry? Yes. So basically the question was the difference between a shared and exclusive cluster. So it's basically how you want to divide up the cluster. If you want all developers basically one single namespace have full admin access to the cluster, or if you want them to have more siloed parts of it. So it's basically just if you want it multi-tenant or not. So it's just the two different ways of setting up the cluster. Any other questions?
Is this purely for a development environment, or do you ever see any kind of production?
Sorry, can you hold a little closer?
Is this purely for development environment, or do you see this ever being deployed as production or even minimal production?
So the question is if we see this just as something that's being deployed for production purposes, or for development purposes, or in production, and I would say both. I mean, we have this was released a couple of months ago. This is fully supported, fully GA, and we have customers that are going to put this into production or work on putting this in production to run regular production workloads on soon.
Hypervisor, and then you would have OpenStack hypervisor on top of it, and then you would have Kubernetes running inside as VMs on top of it, and then containers running within it. So that's almost 4 layers of, or is it more like Kubernetes is installed also as a VM at the VMware level, where the controllers are installed within OpenStack environment just for controlling the Kubernetes for containers. So I'm just trying to understand the levels of virtualization here and how it would affect production workload if you ever deployed it this way.
Yeah, so the question was how many layers of virtualization we get with this stack. And so there are basically, I mean, two ways for deploying containers today. Either you deploy your containers in VMs, or you deploy them on bare metal. So like the majority of companies we talk to want to deploy them in VMs. So this is basically that. Yes, we deploy them on ESX, and then we deploy the containers in the VMs, but there's no more layers of virtualization there than any other way of deploying containers into VM. So we have, yes, there's an OpenStack layer that our Kubernetes platform talks to, but there's no extra virtualization layer there. That's just how the orchestration and the deployment of those resources and containers happen. I think we have time for one more quick question before they kick me off stage.
For collaboration purposes, so if you want fine-grained control for a user to share a container, example in a university environment, they develop some application or something along those lines in research space. And how do we control, is there a way to control the permissions based on user groups or for collaboration purposes?
So the question was, how do you control basically role-based access, or how do you control access to this? So I think it depends on what you want to do, and we can take the question offline. But you have the namespaces in Kubernetes, and you have your users and groups in OpenStack. You can use to enforce that. So I think it depends on a little bit exactly what you want to do. And then we also have the two types of clusters, shared and exclusive. If you want to have everyone using the same cluster, or if you want to have them more isolated and not interfere with each other. So I'm happy to talk to you in about 5 seconds, and we can explore exactly what you want to do and drill into that. Thanks, everyone.